in section 8.3 is all about graphing f of x is equal to ax squared plus bx plus c. So we've done just graphing ax squared. We've also done graphing ax squared plus c. Now we're going to add the middle bx part. So some things are still going to be exactly the same. Graphs will open upwards for a greater than 0. So that will look like that. And the graph will open downward if a is less than 0 or a is negative. The y-intercept is always going to be equal to c. So the single digit on the end is going to be equal to c. So you know how in your linear equation y equals mx plus b, the single digit at the end, that's your y-intercept. Same case here for your parabola. The x-coordinate for your vertex will be the following. The negative b over 2, the opposite of b over, I almost did it again, over 2a. This is also your axis of symmetry. X is equal to opposite of b over 2a. So for this equation, f of x is equal to 2x squared plus 8x minus 1. I want to find both the vertex and our axis of symmetry. And it's going to be easier if we actually find our axis of symmetry first, because that's going to be the x-coordinate of our vertex. So why don't we go ahead and find our axis of symmetry first. And for that, we just need to identify the following: b and a. So in this equation, b is equal to the number 8. It's going to be with our singular x. And a is going to be with our x squared, which is equal to 2. So we're going to take x is equal to the opposite of b over 2a, which is equal to negative 8 over 2 times a 2, equal to negative 8 over 4, or negative 2. So our axis of symmetry is x equals negative 2. And now with that information, we can find our vertex by plugging in that x value of negative 2 into the equation. So f of negative 2 is going to equal 2 times negative 2 squared plus 8 times a negative 2 plus 1. And when we solve that, we will get the y-coordinate for our vertex. Notice we already have our x-coordinate. So that's going to equal 2 times a negative 2 squared. Negative 2 squared is going to be a 4 plus a negative 16 plus 1. 2 times 4 is equal to 8. That's going to be a negative 16 plus 1. 8 minus 16 is negative 8 plus 1. Oops, I did this when I wrote the notes too. Notice we have a negative 1 here. That needs to be a negative 1 all down there. I just copied down the problem wrong. Negative 8 minus 6, or sorry, 8 minus 16 is a negative 8. Minus 1 is going to be equal to a negative 9. That's our y value. So our vertex is going to be our x and our y combined for a negative 2, negative 9. So the reason why you want to be able to find your vertex is you know that your vertex is going to be the very center point of your parabola. And if you know your y-intercept is C and your axis of symmetry reflects that, you only need to find 1 point to graph a parabola. So why don't we go ahead and graph the following then? So we're going to graph f of x is equal to 3x squared minus 6x plus a5. Our first step is to find our axis of symmetry. And to find our axis of symmetry, we are going to plug into the equation x is equal to the opposite of b over 2a. B is equal to a negative 6, and a is equal to a positive 3. So we're going to go ahead and plug that into that equation. The opposite of a negative 6 is going to be a positive 6 over 2 times a 3. So that's going to be 6 over 6, which is equal to 1. So our axis of symmetry, x is equal to 1. And so if we go ahead and draw a graph over here, and actually looking at this graph, we're going to need to be kind of centered over on the quadrant 1 of our coordinate plane. So I will do that. And I'm going to go ahead and draw in our x is equal to a positive 1 axis of symmetry right now. There we go. Step number 2, we are going to go ahead and find the entire vertex. And to find the vertex, we're going to do that in yellow. And that is just plugging in this x equals 1 into our equation. So we're going to go ahead and plug in f of 1 is equal to 3 times a 1 squared minus 6 times 1 plus 5. 1 squared is just going to be 1, so that's a 3 times a 1. 6 times a 1 is 6 plus 5. So that's 3 minus 6 plus 5, or in other words, a positive 2. And so our vertex is equal to the coordinate 1, comma 2. So we'll go ahead and draw that on the coordinate plane right there. And then finally, step number 3 is going to be utilizing our y-intercept. And the y-intercept is just equal to the plane number at the end, or the term c. And so c is right there. And so c is equal to 5. And so our y-intercept is equal to 5. So we're going to go to the y-axis, go up 3, 4, and 5, and now go over 1 and then go over 1 more. So we mirror that on our axis of symmetry, and we're going to complete our graph. And that is how you graph a parabola using just the axis of symmetry, vertex, and y-intercept. It's a way quicker process than making a table, because you'll eventually get to a point where you can do most of it in your head. Real quick, I want to talk about the domain and range of this function. So the domain, or in other words, what can x be? That's going to be all real numbers. Any number x can plug in there. And our range, or in other words, what can our y be? Notice that our y's plateau down here at a 2. And they can be equal to a 2, so we're going to say y is greater than or equal to a 2 for our range. So on every parabola, the domain is always going to be all reals. And the range is going to be whatever your y value is in your vertex. If your graph opens up, you'll be greater than or equal to. If your graph opens down, you will be less than or equal to. And we're going to go ahead and talk about that now as a new term known as max and min. So let's look at maximum and minimum on a function. So if I draw a generic parabola here, so there's our parabola. There's going to be a point on this parabola that is lower than all other points, and that is your minimum. And you will always have a minimum if your graph opens upwards, or in other words, a is greater than 0. So if your entire function looks positive, then you're opening up, you're going to have a minimum. You can also have a maximum, or a point that is higher than anything else. And so on this parabola, that's going to occur right there. That point is higher than any other point on the y-axis. That is going to be known as a maximum. And that occurs when a is less than 0. And you find your max or min because the y value of the vertex is the max or min value. You just have to use a little bit of brains to know if that's opening up or down, whether it's a max or min. So notice right here, our y value of our vertex was 2. So our minimum on this graph is equal to 2, and is also our range. And since the graph is opening up, we are going to be greater than. All right, so we're going to go ahead and tell if the function has a max or a min, and then we're going to find it. And so if we look at the function f of x is equal to a negative 4x squared minus 24x minus 19, we know that if a is greater than 0, you're going to have a minimum. And if a is less than 0, you're going to have a maximum. And in this function, your a term is equal to a negative 4, and that is way less than 0. So you're going to have a maximum here. And to find it, we must find the y value of our vertex. So we have to find our vertex. So to find our vertex, we have to plug into the function x is equal to the opposite of b over 2a. And we already know that a is equal to a negative 4. Notice that b is equal to a negative 24. And so this is going to be x is equal to a negative 24. The opposite of that is going to be a positive 24 over 2 times a negative 4. So that's going to be 24 over negative 8, which is equal to a negative 3. But we don't want just the x coordinate, we need the y value. So we're going to go ahead now and plug in a negative 3 into our function to find our vertex. So we're going to take f of negative 3 is equal to negative 4 times a negative 3 squared minus 24 times a negative 3 minus 19. That's going to be equal to negative 3 squared is going to be a positive 9, and 9 times a negative 4 is going to be, what is that? 9 times a negative 4 is a negative 36. Negative 24 times a negative 3. 24 times 3. It's going to be a positive 72. And then we're going to minus our 19. So we're going to take negative 36 plus 72 minus 19. And that is going to equal a positive 17. And that 17 is our maximum value.